Hey everyone, this is page 2 of the chapter 1 test review, starting here with number 4. So number 4 gives you the formula for area of a trapezoid, and it says give a reasonable domain for H. And I just want to point out this word domain. We stumble on this a lot. What is this really asking? And the thing that I hear the most often is, oh, domain is X. You have to be a little bit more specific about it to make it make sense in your brain. Okay? Domain is saying what numbers can go in place of the independent variable? What can I plug in for X? Okay. What numbers am I allowed to put in for that X value? Or in this case, it's talking about H, okay, not X. But you're right. When I say domain and you say, oh, it's X, you've got the right idea. It has to do with the X, okay? But it's what numbers is X allowed to be. So thinking about this, in this problem, the H represents height of a trapezoid. And so I want to know what numbers could I plug in for the height. It may actually be easier to think about what numbers could not go in place of H, what numbers would not make sense, okay? And I would say that H, the numbers that don't make sense would be negatives. I can't have any negatives. Okay? Because you can't have a negative height. And so then when I say reasonable domain, I want to say, all right, so what does that mean H is allowed to be? And I would say something along the lines of H just has to be greater than 0. Okay? Or I could say H is positive. Okay, either one of those is okay. H has to be greater than 0 or positive. If you got more specific with like rational numbers or real numbers, that's perfectly fine. I did have some people say whole numbers. Keep in mind that you could have a height of like 2.5. So whole numbers would not be correct here. Really what I'm looking for is just the fact that it has to be positive. Okay, so use the formula to find the area of the trapezoid at the right. Now, back to this question, one of the wrong answers I see a lot is people want to look at this trapezoid and go, oh, 7. Keep in mind, this is one specific example. This question is asking in general about this formula. Okay, so it's not talking about this one. This is only used for part B here. So I'm going to do this. I'm going to do 1/2 times my height of 7 times B1 plus B2. And just so we can be clear on how that's being typed into the calculator, I would go 1/2 or 0.5 would be fine, times 7 times parentheses 10 plus 24. And I get 119 again. Gosh, I feel like I got 119 before for something too. And I didn't give units here, so I would just say square units, whatever it happened to be. Centimeters, inches, doesn't matter. Okay, we stumbled over this a little bit on the last quiz. Rewrite the formula for B2. This wording here is the same thing as me coming along and saying solve for B2, meaning get it by itself in the formula, okay? So again, I'm not looking at this question specifically. I'm looking back up here at the formula, okay? Get B2 by itself. This whole thing about in terms of H and B1, that just means that your answer is going to be B2 equals blah, 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 but something that includes H and B1. So let's try it. Here's my formula. This is what I'm digging for, okay? I always start with the fraction though, so I'm going to multiply by 2. Remember, don't divide by 1/2 here, okay? Because that's going to look ugly on the other side. So now we have 2a equals h times b1 plus b2. I can't dig into these parentheses until I get rid of the guard on the outside, right? And so that h needs to go next before I can get in there. And so I would divide by h. Okay. Just going to draw a quick arrow and go this way. So now I have 2a over h equals b1 plus B2. If I'm trying to get B2 by itself, I'm going to subtract the B1. And just be careful when you write this left side. Gosh, I've given myself very little space here. We'll go up here. And so I would write something along the lines of 2A over H minus B1 equals B2. And that's what my final answer is going to look like here. And notice, I've solved for B2, meaning I've gotten B2 by itself, in terms of H and B1. Okay, so I've given the answer in terms of those other variables. That's what that means. Okay, let's look at number 5. Number 5, first it says determine if each is recursive or explicit. So visually you should be able to tell the difference, which is which. But just to review here a little bit, recursive are the ones where you get to the next term by doing something to the previous term. Okay, so it's jumping from one term to the next. Explicit is when you can just plug in whatever term number you happen to need and the formula is going to spit it out for you. So that's what's going on here in letter A. Okay, this one here is explicit. Okay, because when I want term 1, I'm going to plug in a 1. When I want term 2, I'm going to plug in a 2. And so here's what that's going to look like. S1 would be 1 squared minus 1. I'm going to crunch the numbers in just a second, but S2 equals 2 squared minus 1. S3 would be 3 squared minus 1. S4, 4 squared minus 1. And S5, 5 squared minus 1. Notice I did not need the answer for S1 to be able to do S2. Okay, and if I had wanted to jump straight to S5, I could have. That's what an explicit formula does. Okay, it doesn't really care about the answer that you got for the previous term. We do need to go in and fill in what these actual terms are. So let's see, 1 squared minus 1 is 0. 2 squared minus 1, that's 4 minus 1, so that'd be 3. 3 squared minus 1 would be 8. 4 squared is 16 minus 1 is 15. And 25 minus 1 would be 24. Okay, and so my sequence would be this right here. Okay. B, on the other hand, is recursive. Okay, and you should be able to tell that just by looking at the formula. Okay, and so in a recursive formula, they always give you the first term. So I know that my first term is 2. Okay. When I want term 2, what this thing is saying is I'm going to do negative 2 plus 3 times, and then this thing right here is always talking about the previous term. Okay, so this is really saying take this 2 that I had from before and put it right here. Okay, so let's see, this would be 6 plus negative 2, which is 4. And for this one, you'll notice that I have to calculate them as I go because I can't calculate the next term until I know what this one is. So when I want S3, I'm going to do, again, negative 2 plus 3 times, and I'm putting in the 4 from right here. Okay, and so that's going to give me, let's see, 12 plus negative 2, so that's going to give me 10. Term 4 would be negative 2 plus 3 times the 10 that I have sitting right here. Okay, that's 30 plus negative 2, which is 28. And then finally S5, negative 2 plus 3 times whatever my most recent term was, so that's the 28. I might be pressing a little bit here. Let's see, 3 times 28, that's going to be 108, I believe. And that doesn't make sense. 84, I mean. Sorry, 3 times 28 is 84, plus the negative 2, so that would be 82. Okay, let me just double check that one. Make sure I got that right. Yeah, 82. Okay, so with this one, I didn't really need to look back at this formula every time, right? That stayed the same every time. But the number I was plugging in was no longer the term number. It was not this number. It was the term that I got on the last one. Okay, that's how a recursive formula works. So speaking of recursive formulas, the next question asks you to write one. Okay, and by the way, recursive definition means the same thing as formula. So when you see definition for recursive, I want you to think formula, which looks like this. So I need two things. I need term 1, which is 16. And then I need to say, how do I get from one term to the next? So I'm always going to start like this. The next term in the sequence is found by taking the previous term and doing what to it. And so when I look at this sequence, it looks like I'm going down by 3 each time. So I'm going to put minus 3. And then that's my answer. That's my recursive formula. Okay, switching gears a little bit, back to functions here with number 7. Does this function, or does this table below describe y as a function of x? So remember, when the sentence is written this way, this right here is meant to be your independent variable. And that's the place where each number can only have one partner. So we want to make sure we don't have double ups. And right here, I see -1 with 1 and -1 with -1. So because this repeats right here, I would say no, because -1 is paired up with more than one value. Just to clarify, remember it's really only the independent variable that we care about those repeats. Oh, sorry, you can't see my answer there, can you? It's only the independent variable where I care about that. If it had happened down here in the y, I wouldn't have cared. Okay, so it's only if it's in the independent variable that we would say no, it's not a function. Okay, I'm going to carry on in another video with page 3. That does it for page 2.